All right, so this is my creating paper circuits, and as you could see in my lesson plan, I decided to connect it to National Lampoon's Christmas Vacation because I thought that would be kind of a funny kind of hook, and it could be an interesting project to do around the holidays. And basically, my thought process was for the students to create a circuit that would light up holiday lights. And so I kind of went through the basic steps that they would use to just kind of figure out how circuits work. And then they would kind of take that information that they learned in order to create some kind of light display. So, first, as far as the plan, obviously I would give them the similar materials that we were given in the Chibi LED lights. Circuit sticker kit, which, as you can see, all of those materials are listed here. They could also use paper or cardboard for when they're actually creating their displays that would be like on a house. So like I kind of used the chibi box because that's kind of where I got the idea from, because I thought like, oh, they could just string different color lights and it could be a little thing like that. So then, as far as designing, I know that in chapter 6 it talked about making sure that you don't give scaffolds right off the bat and you kind of let kids just explore. And that definitely helps them to kind of develop that engineering mindset that sometimes it's not always going to work the first time and you have to really think through it and try to improve. So I drew just like a basic circuit and then kind of used what was in the sketchbook, even though, I should have just kind of tried to figure it out first. And then I created, which, as you can see here, I failed a few times before I was actually successful. I tried out a bunch of different things, but then down here at the bottom, I was able to successfully light it up. And I think that students would have to go through this similar kind of project in order to first understand how the circuit systems work and then kind of build more intricate systems from there. So as far as improving, then I kind of started to play around a little bit with, could I do a parallel circuit? Could I somehow connect one to the other? Because if I was going to do a string of lights, I would want to make sure that I had a way to kind of connect them. So this is not a pretty looking one, but I was just trying to experiment a little bit. So next steps, then students would work on creating switches that turn the circuits on and off. Just like Clark from Christmas Vacation, they could create more intricate designs to actually put on like a cardboard house is what I'm envisioning, or like maybe a little gingerbread house type thing. Something that looks like it. I don't think it would probably work on gingerbread. And then I also struggled a little bit with the copper tape. I don't know if anybody else did, but mine seemed to like rip pretty easily when I was trying to create that continuous loop, because that was some of my struggle, was trying to figure out why mine wasn't lighting up. And then I realized after reading the directions, you had to have that continuous loop, and mine kept ripping, and then I would have to start over again. So trying to think through that. And then as far as considering STEM practices, I really did feel like this had the potential to have a lot of STEM practices. Obviously, in science and engineering, we're defining problems, we're developing models, we're carrying out investigations, we're analyzing our data to try to improve it. But I also felt that it kind of connected to the technology piece, because I know in my lesson plan, I talked about some of the cross-cutting, being that sometimes we change designs, and those designs change because technological advances happen. And I think like understanding like, okay, we know how a basic circuit works, but now how can I improve it and make it better? That's showing an improvement in that circuit technology. And mathematics, I also felt had some more practices that were incorporated. Definitely attending to precision, because if you didn't have the tape just right, or like I said, it wasn't a continuous piece, then you really could have a circuit that didn't work. And I also think if this was done in small groups, that you could definitely have a discussion and have some kind of like critiquing of what others think might work and what isn't working and how they can improve their designs. So that's a little bit about the STEM lesson that I would